Hello and welcome to this short film which shows a new technique for imaging retinopathy of prematurity on the Optimap wide field camera. Please look at the Eye Research logo and the film will begin in just a moment. A speculum is inserted in the right eye by one of the nursing team and the baby is held by the consultant. The baby is now turned over onto its front, resting on the consultant's right arm with the chin and neck being supported with the right hand. The head is held with the left hand resting on top of the baby's head to maintain stability and to assist in the aligning of the eye with the camera. If you look at the screen to the right of the camera, you will see the images that are being captured. You will see how small movements made by the consultant affect the distance of the eye from the camera, which in turn determine the results. The consultant rests the side of his left hand on top of the camera, which allows these small movements to be made while knowing the working distances at all times. Having a team of people available is essential as assistance is required. Here we have two nurses working alongside the consultant. Once one eye has been imaged, the consultant moves away from the camera and rolls the baby over so the speculum can be removed. We use a variety of different size speculums, which is determined by the size and age of the baby. A blue open-bladed speculum has been selected for this particular case. The nurse inserts the speculum into the left eye, administers more drops, and the baby is rolled back onto the consultant's arm, with the chin and neck being supported again with the right hand, and the left hand holding the head. The process is now repeated with the left eye. Again, if you look to the right of the camera at the screen, you can see the importance of getting the alignment correct. The photographer is able to track and follow the eye to an extent by using the directional control of the camera controller. When the circular icon on the screen goes green, the working distance from the eye to the camera is correct and should produce the best results. The icon flickers between red and green because of the constant movement of the eye. This illustrates the impact movement has on the duration of the procedure. It is the responsibility of the photographer to take the image when the light goes green. This often means being able to predict when this is going to happen. It is possible to get the image required in a single photograph if the eye is still and if the distance is perfect, but more often than not, multiple images are needed. With the consultant satisfied, we have the results. The baby is rolled back, the nurse removes the speculum, and the baby is passed back to the parent. Here we have the results of the right eye, and then the left eye. This is the traditional way that babies are imaged using the RetCam in theatre under general anaesthetic with a lens that makes contact with the eye. Here are the images taken on the RetCam in theatre, and then the same eye taken on the Optimap in clinic, showing a significantly clearer image with a wider view. Other advances in imaging the retina of paediatric patients include optical coherence tomography. This machine featured here was specially adapted to be used in theatre to image a cross-section of the retina, giving the consultant information that may influence the surgical options. One of the advantages of imaging paediatric patients on the Optimap is that the procedure can be carried out in clinic. By using a dedicated team, further tests such as fluorescein angiography can be carried out showing any irregularities in the retina, alongside indocyanine green angiography that shows the choroid. These tests can give the clinician critical information before diagnosing the patient. Thank you for watching this short film demonstrating new techniques in paediatric imaging, and we hope you found it useful. Special thanks to the staff and patients at Oxford Eye Hospital for their help in the making of this film.